Well, hello, friends. I'm very excited for today. We have another cool experiment. We are going to explore water as ice. Now, for this investigation, I did have to make sure that I prepared all of the materials well in advance because the water had to sit in a freezer overnight and obviously become ice. Okay, so pay attention, and I think you'll enjoy learning some really neat new things. All right, so what we are going to do is I am going to show you a vial here that I have up to a syringe rather that I have up to 40 milliliters of water. Okay. You see where that marking is right there, that black line? 40 milliliters of water. So, what do you suppose will happen if we take this vial and we put it in the freezer overnight? Is the water going to stay? Is it going to go down? Is it going to go up? Meaning expand or contract? Any thoughts? Turn and talk with a friend. Okay, well, let's see if what you said is true. Here, my friends, is our vial, syringe, again, sorry, and this is frozen inside. Okay, that is completely frozen inside. And let's see what happened to the water. Friends, the mark is now up to, look at this, the mark is all up to 45. It's actually at 45. Oh my goodness. So the water expanded. And that's because when water freezes, it expands. So to prove this to you, I also have another item that I froze. What I did was I filled this tube all the way to the top. Okay, that water is all the way to the top there. And I secured it like so. Okay. And then I took it and I put it in the freezer. And what came out of the freezer was look, look what came out of the freezer. Whoa. Look what happened to the water, friends. Do you see that at the very, very top there? So that's the edge. And all of that water is well above it. Okay. So what happened was the water expanded when it froze. Okay. Now, what about if we were to look at the weight of 100 milliliters of water? So, what I have right here is 100 milliliters of water. Okay. And again, that's just two of these syringes. Okay. Obviously filled with liquid water, not frozen water. And I put two of those syringes in here to make 100 milliliters of water. Then I took that and I put it in the freezer overnight. And here is what happened. Okay. It became solid, it became ice. Okay. So here we have 100 milliliters of water, liquid water, and 100 milliliters of frozen water. Okay. It's the same volume, which means it takes up the same space. Is it possible that one could weigh more than the other? Could you make a prediction as to which one might weigh more, or are they going to be balanced? Okay, let's see if your prediction came out correct. We are going to take a scale that I have set up right here. Okay, making sure our scale is even. Okay, is balanced. Sometimes you need to play around with it a little bit to make sure that it is 100% balanced. We don't want it to be one side versus the other. Okay. And we're going to take our cup of ice water. I'm going to put it over here. Okay. And then we're going to take our cup of regular liquid water. Oh my goodness. Look at that, friends. Look what happened. The regular liquid water actually weighs more than the ice water. Why do you suppose that is? Oh my goodness. Go ahead and turn and talk as to why you suppose the liquid water weighs more than the solid ice water. Okay. So, since there's more liquid water it weighs more. Okay. So here are some vocabulary words, some things that I wanted to point out to you because this is really important to your response question. When water freezes, it expands. Water gets bigger and fills more space when it turns to ice. Water changes into ice at 0 degrees Celsius or 32 degrees Fahrenheit, changing from liquid to solid. And water contracts as it cools. So we're going to take a look in a few minutes and see what happens to our syringe. And the syringe I had, the syringes. We're going to see what happened to our syringe. Here they are. If it starts to melt, will it return to 40 milliliters again? And what will happen here? Will this contract as well when it melts? So I'm going to put that aside. And while we're waiting for that to melt, I have one more thing I wanted to do with you. And that is here I have a cup of plain water. Okay. And what I did was I froze some blue ice cubes. Yeah, just a little bit of food coloring. And that way you're going to be able to see what happens when we put the blue ice cube in the water. So what do you predict is going to happen? Is it going to sink? Is it going to float? Is it going to stay intact? Is it going to melt? What do you think? Turn and talk with a friend. Well, let's see if your prediction comes true. So I'm going to take one of these ice cubes out. There's a beautiful blue ice cube. Okay. And I'm going to take that beautiful blue ice cube and I'm going to put it in our cup of water. And we're going to observe very closely what happens. Okay. Here we go. Just wait and watch. See what's going on there. Ooh, look, friends. Do you see some of the ice cube is starting to disintegrate? And look at that. Whoa, it's going to the bottom of the cup. Now, why is it going to the bottom of the cup? I'm going to set it down and let you take a look. Continue to look and observe. Okay. What happened when the blue ice was placed in the water? Well, those small streams of blue are flowing off the melting ice cube and sinking to the bottom. Why is that? Well, cold, dense water sinks. So what do you suppose is colder? Now, I'm not going to touch the ice cube there, but what is colder? The ice cube, okay, or the blue water? The blue water was colder after it melted from the ice or the clear water, okay? And you can still continue to see as I hold it up, okay, as it's continuing to drop there toward the bottom. All right, so we're going to pause for just a minute and then we're going to take a look at what happened to our syringes and our test tubes to see if they contracted after melting. Okay, so here we have the frozen syringe. And look at that, friends. We have this again, it's completely frozen on the inside. However, it is starting to melt. And look at that, it's going back down to 40. Which proves that when water melts, it contracts, okay? And the same thing over here. This was our clear water, okay? And then look what happened on the inside. It's starting to melt, but instead of it being overflowing on the top, I can stick my finger in there and it is contracting. Okay. All right, that brings us to our response sheet on observing ice. What you're going to do is draw a picture of a vial of liquid of water and a vial of frozen water, and then answer these questions. What was the volume of liquid water in the syringe before it froze? Well, we know the volume was how much? Do you remember what the volume was? It was 40, right? And then after you froze it, it became 45. And what was the difference in volume? 45 minus 40. And write a sentence to describe what happens to the volume of water when you freeze it. All right. I hope you learned a lot, and I'll see you in the next session. Bye-bye.